Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Chris Jackson, and we're not dealing with, but we're going to talk about the enduring problem of no fault found.
Well, yeah. That's one way it was phrased. It was a question from a couple months ago, and I kind of realized, we hadn't talked about this one yet. Somebody I correspond with on a regular basis, he said, what do you do when your prototype during the development phase fails? And I said, did the rest of the team say, oh, it's just a prototype, ignore it? And he goes, how'd you know? Well, let's talk about this. I think what I've also seen, and I'm quite sure you have, Chris, and probably all of our listeners have seen it, is there's a field failure and there's no trouble found. You put it back on the bench and nothing happens. I know Kirk and I have talked about it. Well, that's a candidate to put it in the halt chamber and find out, more about where its weaknesses. Maybe nominal stresses just don't apply. And there's also comments of, well, they abused it. They did something bad to the product. It's their fault. And that's a slippery slope. It just becomes way too easy to dismiss ones. And the worst example I ever saw with a client was they had a whole gauntlet of things that went on before they would accept that it was an actual field failure. And so that their field failure actuals, air quotes around that, were acceptable to the management reporting in it. And so they had all kinds of stuff coming back and all kinds of things failing, but they didn't count no trouble found. They didn't count customer abuse, whatever that meant. They didn't count all kinds of stuff. And it wasn't until they could get it to a very blatant, that this wasn't constructed correctly, basically a manufacturing defect. They didn't count design flaws. You got to be kidding me. Now, have you ever heard me say, Chris, that failures are gold?
Yes. I don't think I've heard you say that phrase, but I know you've expressed that sentiment quite vigorously over the years.
Yeah.
And it's because it's a treasure trove of information. The no fault found ones, and those are systems which you can really exploit. I mean, the easiest thing to do is just say no fault found. Therefore,
well, if you don't look, it makes it really easy.
Well, that's true. But the whole idea is that the customer is an idiot. They don't know what they don't even know how to operate it, or they might have pushed the wrong buttons or whatever.
Mm-hmm.
Whatever narrative you come up with to make it to diminish it before you go on lunch. But they're often the precursors of bigger issues. So if you have something coming back and there's no fault found, there's a good chance that yes, there was an issue, and that issue's just under the surface of lots of other platforms or systems. And if you can get to the bottom or work out why, even if you can't find out the fault, if you work out, hang on, there is something different about this. This has got, corrosion over here that just insert, exploratory answer to exploratory question. If you really want to investigate it, there's a better than average chance that you're going to find out some new way your thing is degrading to the extent you might be able to get ahead of the curve and not have to issue a huge recall or have your company appear in the newspaper or get sued by customer X because it exploded or et cetera, et cetera, et cetera.
Yep. Now that takes time. And a good number, especially consumer products, is they send it to a third party, we got this serial number, you can issue the refund, and then it goes in a bin. Just never seen again. It takes time and resources and so on. So there's some organizations, and I'm quite sure none of the people listening to this are in an organization like this, where it's not worth our time to sort it out because we're not going to do anything about it anyway. And I think they're just throwing away so much valuable information that, even a sampling of those things, of the returns, would help a whole lot. There's a bias in development and in with field failures that I find disturbing or difficult. And given the pace of innovation and the deadlines and all the other pressures that are on teams at all phases of the life cycle, it's an easy out. Is we're going to come up with our favorite 10 excuses why we're not going to deal with this. And I think is very short-sighted. The original question was, they were running a test, and they were running a test to pass. They had a handful of samples under these certain conditions, and the test was designed that if they passed, they were good. And I think we talked about maybe it's another topic for us. Is the second part of that question was, well, one of them failed, and we took it out and we put in a brand new one so that we would have the 22 units run for the duration of the test, and we just ignored the failure. I said, well, there's all kinds of things wrong with that, but ignoring why it failed was top of mind to me. And he said, well, it was a prototype, and the team looked at it and said it was because of the prototype that it actually failed. Now, I didn't get a whole lot of details about what system it was, what kind of product they're doing. What was this, using standard parts and finished molding or something like that, or was it using a bunch of mock-up breadboard kind of stuff? And it wasn't clear as to what extent just being a prototype was the cause of the problem. Yet I've heard that. I've been in product testing, and they say, well, that was just a prototype. They always fail. And it turns out that things you see in prototypes are often the precursors to big problems when you get to the field if you just ignore them.
Right. But there are some prototype failures you can perhaps, air quotes, ignore. So, for example, if your prototype involves soldered joints, but you know that you're going to have cable connectors in your final final production prototype, well, that's okay. I mean, cable connectors come with their own fleet of issues, but they're often a lot less troublesome than solder joints in many cases. A lot of solder joint issues can be created through assembly and manufacturing issues. Even if the solder joint was done well, when someone pulls that cable and they're trying to solder the other end to the other part of the system which needs it, et cetera, et cetera, et cetera. And so cable connectors and sockets and plugs are often better because they assist assembly. Just insert lots of really good reasons you want to use them. Of course.
Well, I think generalizing that, Chris, would be if the prototype is using, shortcuts just for the sake of the prototype, because we don't have final parts yet. We don't have this, that, or the other thing. It's easier to assemble the proto. For example, we know the outside is going to be stamped metal, but we're using a 3D printed polymer instead. And if that outside polymer fails for whatever reason, well, that's not our final product. We know that. So it's worth understanding where the stresses are coming from. But beyond that, we're not going to fix the 3D printed polymer mock-up that we're doing, kind of thing. If the prototype is markedly different than the plan, yeah, you got to discount that to some extent. I wouldn't ignore it. Why did that fail? And if we're going to metal, but we can't, it's way too expensive to build those right now for the 20 that's protos we need. I get that. Yet, if it melted, well, why do we have that much heat?
Yes, right.
Here?
Yeah.
Kind of thing. So it's that was the original question, and we got into that a bit. It's a different topic about what do you do with your test regime or test plan. But in the field, I've run into way too many of them where, you mentioned it right off the bat, is no trouble found. And some of that is that we're not looking very hard. I think the biggest one I ever saw, and I know I've told this story before, is I got called down to the shipping dock, and there's a whole pallet packed exactly the way we ship it out of the factory, came back as a return. Or all failed units. They weren't even taken out of the packaging. So I was like, what's the real story here? And he goes, and the guy I was talking to says, well, it's really hard to tell if they're working or not because they haven't even been unboxed and plugged in yet. They're still in their factory wrapping at a pallet level. And I said, yeah, that would be hard to replicate and send back to us that way. And none of the box seals were broken. And it was just returned. And so I asked around a bit and I found out that the company had a restocking fee. If you sent unsold units back, there was a restocking fee. And it was, I don't know, 10, 15% of the product's retail price. But if it was failed, if you checked the box that the unit had failed and returning a failed unit, you got the full refund on it.
Oh.
And I'm like, oh, okay. So it's not a design problem. It's not a manufacturing problem. It's a contract problem. So I went and talked to the people doing contracts with the retailers and pointed out that problem. And they took steps to fix that. And that huge chunk, I mean, there were like 600 of these units on this pallet. All of a sudden, we got to take off 600 units off of our no trouble found,
Yeah.
Because there was a problem. It was a contract problem. So sometimes the things that were, when it's looking at a larger problem, it may not be physical. It may not be the software. It may be some other aspect of our business that we need to fix. Customers in general, and I'm going to just say this as a truism, don't return stuff just for fun. It takes time and energy to do it. And I mean, you know what it's like calling customer support for most organizations. It's a pain. Just set aside 2 hours on hold. We don't do it just for fun. It's worth it, our time and energy to get the refund, to do whatever as a customer, to get our system working again. But so it's in my mind, it's always worth then understanding why they went over that barrier to exert enough energy. I'm thinking activation energy for customer returns. That might be a whole concept. What prompted them to do that? There's got to be something. And it could be a myriad of different reasons, but ignoring it is usually a great way to not find out.
And it also comes down to culture. If you've got a culture where everyone's encouraged to try and get to the bottom of the issues as quickly as possible to prevent stuff in the future, then something which appears to not be working is an absolute goldmine of information for that end. If you're just trying to build the wrong thing fast, which a lot of organizations appear to do, then you're going to find reasons to discount them as opposed to reasons to investigate further. I'd rather be speaking from a position of some knowledge. I might not be able to do the detailed chemical analysis and all the modeling and hypothetical stuff and build a physics of failure model about every one of these things. Yet even just scratching the surface a little bit gives you a lot stronger platform going, no, we need to deal with this. Well, I agree. And I think the whole fault, no fault found, what that is in root cause analysis, there's a very specific activity called failure analysis.
Mm-hmm.
And failure analysis is to try and understand the physical reason why something failed. Yeah. So, for example, I was just recently talking about a case study involved Delta Flight 1288, where the fan hub essentially exploded on takeoff on a runway. And shrapnel was flying everywhere, killed 2 people on board. And they were able to work out that some of the a tie rod hole in the fan hub was the thing that physically started it, in that they could see there's a fatigue crack that started. The number of cycles corresponding with the takeoff landing cycles. I think I know that I have a number committed to memory. It was that recently I talked about. It's 12,887 cycles, which is pretty close to the actual number of landing takeoff cycles. So really good evidence to suggest this was a manufacturing issue that was allowed to keep going over time, and essentially the fan hub then exploded, killing 2 people.
Would that be a manufacturing issue or a maintenance issue?
Right. So that's the thing is that doesn't tell you what the root cause of failure was. And what a lot of people think it is, because they're able to replicate the scenario that created the defects, which were ladder cracks, which are associated with drilling. And they spoke to Volvo, the company that was making these fan hubs. And essentially, they would drill the hole first, and then they'd bore it twice. Essentially, everyone knows drilling is problematic. You've got to have it cooled, and if you don't, you have risk of heat-affected zones. Essentially, titanium alloys become very brittle if the temperature goes up. So it's got to be cooled all the time. And when you're drilling titanium alloys or anything else, chips can sometimes disrupt the flow of coolant. So it's just par for the course, so to speak. But every now and then, you'll have 1 or 2 chips block the coolant flow for a couple of revolutions, creating 3 or 4 ladder cracks. Well, not even ladder cracks, 3 or 4 mini valleys of recrystallized titanium alloy because they were temporarily heated above, I think, 1200 degrees Celsius or something similar. And then it was bored out twice, and there was still no cracks, but there was these 2 or 3 microscopic valleys of heat-affected titanium alloy, which are now very, very brittle. And essentially, a few things happened during the inspection. There was a signature for a changed metallurgical structure, but it didn't align with preconceived ideas or signals of metallurgical issues. But the boring is supposed to try and minimize the number of ladder cracks you get from these scenarios by essentially removing more and more surface in a way that hopefully takes away any sort of recrystallized stuff. Boring doesn't take away nearly as much material, so you're less likely to have, chips get in the way of coolant flow, et cetera, et cetera, et cetera. But the NTSB didn't say that was a root cause of failure. The NTSB said the root cause of failure was the fact that this fan hub was subjected to liquid penetrant inspection, and the crack, they could count very clearly the number of striations and work out exactly how big the crack was when it was inspected. And it was over 1 inch long, which, if anyone's ever been involved in liquid penetrant inspection, that is an easy crack to find. It is beyond easy. And for whatever reason,
there's a valley here. It's a chasm.
Right. And that's the root cause of failure. So why I'm torturing you with that long story is that the failure analysis got you to the ladder cracks. And so this is where it started. But the root cause analysis is all about, okay, what were the things we could have done that but we didn't do, or things we did do but we didn't do well, et cetera, which allowed that failure mechanism to propagate. So failure analysis is essentially the scenario where you find ladder cracks, or you get a response from the laboratory or the software guys and girls, no fault found. Now, failure analysis, as we've just talked about, is not root cause analysis. So failure analysis can't give you the answer. It doesn't mean we cancel root cause analysis. It means we need to, frustratingly perhaps, keep doing root cause analysis to try and work out, well, why is a customer reporting an intermittent failure? I mean, that's real. And as you point out, Fred, customers tend to not waste their own time by sending working products back to the manufacturer. That it's just not part of any good business model. If you order something and it works, you use it.
Yep. There are cases where people go, it's the wrong color, it clashes with my clothes today, so send it back. From my own experience working with hundreds of companies, those kinds of returns are exceedingly rare.
Right.
Because of the barrier, the activation energy is required to go do something about it. And I know that you if you can't do anything about it, it's not a root cause. Right. And I think there's that balance. If we need enough information so that where could we interrupt this? Is it by design, by manufacturing, by being very clever how we put the switch on the product so customers can find it, writing contracts so that you really can't circumvent the restocking fee by just calling it a failure, and so on and so on. But the idea is that failures, in my mind, are gold. If they're in a prototype, or if they're in production, or if they're in the field, they all take some effort to understand why. I have found over and over and over again that it's worth it, that you get information out of it. And it may not be germane to your existing product. Let's say you're doing a product launch and it's going to ship for 6 months. You're already well on the way designing the next product. Well, this information is, especially when it's new information, may help you avoid those problems in the future. Different vendor selection, different whatever, process techniques, different design. Now you can capitalize on that knowledge you have and use it. It's just it takes effort and credibility to say, no, we need to do something about this. And by analyzing 100 different particular types of returns or failures or so on, one or two of those are going to be a good business case could be made to, we got to solve this. We got to fix this thing. Uh-huh. And I find that better organizations celebrate failures instead of ignoring failures. I've heard way too many times, oh, we're success oriented. We don't like failures. Well, that's a really poor message to send to your team and to your audience and your customers, to say, oh, it's your fault. Don't talk about it. Let's ignore that and move on. Well, it makes it really difficult to reduce your field failure rate and improve customer satisfaction, all those kinds of things. So there's big pieces on that. Now I picked up a couple of things. I'm gonna have to resend a message back to now I got to find it. I didn't have it printed out on my desk, so I got to figure out who I was talking about. go send it back. But if you're listening to this, one of the issues I find is it's as much the culture of your organization that determines whether you determine why this thing failed and whether you need to do something about it or not, or you just summarily ignore it. So what do you see as you're listening to this makes that difference? That would be a great future podcast. So let us know. Head over to accendoreliability.com/go/SOR. There's a couple of ways to get in touch with us there. We also have, Chris and I are available through LinkedIn and our About pages. There's some weird noise going on in the background. Hope you can't hear that. But if you run across a failure or something not working quite right or symptoms of potential failures, those are all pieces of information we really need to pay attention to. So hopefully that's part of your normal operation. So with that, Chris, I think we'll sign off here.
Absolutely. It's a good chat. Always a pleasure.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.